What we thought we knew about the cosmos is collapsing. Right now, as you watch this, something extraordinary is unfolding in the silent reaches of space. What began as a mere curiosity, a faint, almost forgettable dot flickering across a telescope sensor, has evolved into one of the most unsettling astronomical enigmas in human history. It's as if the universe itself just whispered a secret we were never meant to hear. For months, it hid in the data streams, an object cataloged, tagged, and promptly dismissed by most of the global observatories. Another comet, they said, another icy traveler from the void. But that label, it didn't last long, because the object now known as 3I/ATLAS refuses to behave like anything we've ever seen before. Harvard's most provocative astrophysicist, someone not known for mincing words, has now gone on record saying this might not just be another interstellar rock. In his own words, 3I/ATLAS could represent nuclear-powered technology originating from beyond our world. A statement like that isn't made lightly, and yet the data leaves little room for comfort. When astronomers first tracked the faint glimmer emerging from the black, its trajectory instantly caught attention. It was moving too fast, following an open-ended hyperbolic path that mathematically confirmed it wasn't born here. Not in our system, not in our sun's gravitational reach. It came from elsewhere, from the unfathomable dark between the stars. But that's where the familiar story of science ends, and the real mystery begins. Initially, the classification seemed clear. Humanity's third confirmed interstellar comet. First, there was Oumuamua in 2017, then Borisov in 2019, and now Atlas, supposedly another frozen relic ejected from some distant sun. A thrilling find, sure. A statistical miracle, absolutely. But a natural one, right? That's what everyone believed, until the numbers stopped making sense. As more data streamed in, data of unprecedented precision, thanks to instruments like NASA's Hubble and the James Webb Space Telescope, the comfortable narrative began to fracture. What was supposed to be a simple comet began breaking every known rule in the astrophysics playbook. Its coma, the gaseous halo surrounding its core, wasn't just expanding, it was exploding. Not metaphorically, literally expanding at rates so rapid, so violently excessive, that researchers initially assumed their instruments had malfunctioned. The readings were off the scale, growth rates thousands of times greater than those of any known comet. Imagine watching a city balloon into the size of a planet in a matter of weeks. That's what this looked like. At first, astronomers thought the object's nucleus must be small, perhaps just a few miles across, like most comets we've cataloged. But those size estimates were annihilated as the coma continued to swell, surpassing 400,000 miles in diameter. For perspective, that's more than half the diameter of the Sun. You could fit Jupiter inside its glowing shroud with room to spare, and yet it didn't break apart. By all known physics, it should have. The pressure from that kind of outgassing, the violent venting of material, should have ripped the nucleus into a million fragments, just like what happened to Comet Atlas C/2019Y 4 or 5 years ago. Back then, that object brightened, fractured, and vanished into dust. A spectacular but predictable demise. But 3I/ATLAS is different. It defied the pattern. It defied everything. Despite the massive internal pressures, despite the furious energy release, it held together, intact, solid, unyielding. And that, scientists realized, changes everything. If this object were truly a loose pile of frozen dust and ice, the dirty snowball model that defines all comets, it should have been obliterated. Instead, it's as though something engineered to withstand catastrophic stress resides beneath that glowing veil, something built for endurance. Across labs and observatories, the tone of the discussions shifted from curiosity to disbelief, from disbelief to quiet alarm. No one wanted to say it aloud, but the implications were becoming impossible to ignore. That's when Harvard astrophysicist Avi Loeb broke the silence. He proposed that we might not be looking at a natural object at all. To navigate the debate, Loeb suggested a framework. a natural to technological scale, ranking objects from 0 to 10. A 0 represents the familiar, a natural asteroid, a comet, an Oort cloud fragment. A 10, a verified technological artifact, an engineered creation not of this earth. Where does 3I/ATLAS fall on that scale? Loeb didn't say explicitly, but his tone, measured, deliberate, unmistakably cautious, suggested the needle is drifting higher than any of us are comfortable admitting. The strangeness doesn't stop with its physical behavior. Even its light is wrong. As Atlas approached the inner solar system, its brightness began fluctuating wildly, flaring, dimming, flaring again, with no discernible external cause. Comets brighten as they heat up, yes, but not like this. Not in sudden chaotic bursts. It was as if something within was reactivating, like a machine cycling through different power states. And when NASA directed Hubble to take a closer look, what it saw only deepened the confusion. The coma wasn't a calm spherical cloud like every model predicts. It was turbulent, violent, structured, columns of matter jetting out in precise directions as though ejected from nozzles. Scientists stared at the data, trying to reconcile the patterns. The jets weren't random, they were organized, and hidden within the maelstrom, the core remained eerily concealed, its true form masked by its own brilliance. Spectroscopic readings soon revealed more shocks. Instead of the familiar chemical fingerprint of water ice, Hubble and JWST detected heavy elements, complex carbon compounds, and shockingly low levels of H2O. In simple terms, this wasn't a comet as we know them. It was something chemically unique, almost industrial. Some researchers quietly began comparing it to an energy reactor, an object containing dense volatile materials that could explain its violent outgassing. But that idea of a reactor drifting through interstellar space was too radical for many to accept. Still, the numbers were unrelenting. This object was shedding mass at rates thousands of times higher than any known comet. Thousands. To comprehend that, imagine a mountain disintegrating every few hours, yet somehow the structure beneath remains stable, solid, intact, and purposeful. And then came the most disturbing revelation of all. When Hubble's imagery was processed to examine the tail, the iconic feature every comet possesses, astronomers froze. Something was wrong. Comets always have tails that point away from the sun, driven by the solar wind. That's an immutable law of celestial mechanics, always. But 3I/ATLAS didn't obey, because along its front edge, in the direction of its travel, Hubble detected something utterly impossible. A narrow, coherent beam of light projecting forward into the darkness, a headlight. The images were checked, rechecked, processed by multiple observatories, and they all confirmed it. This was no artifact of digital interference, no trick of contrast. There was an actual forward-projecting, laser-like emission, something entirely foreign to natural behavior. At that moment, the mood in the scientific community shifted from intrigue to dread, because this wasn't just a comet acting weird. This was a celestial object violating electromagnetic law. Natural processes scatter light, they don't focus it. Nature diffuses, it doesn't collimate. To maintain a stable, forward-projecting beam requires coherence, organization, intention. And so, for the first time in recorded astronomy, researchers were forced to seriously consider the unthinkable. Were we watching a controlled object? Across midnight discussions and encrypted academic exchanges, speculation turned feverish. Could it be a propulsion system, a photonic engine perhaps, using directed energy for minute course corrections? Was it a communication laser transmitting across interstellar distances? Or, as some quietly feared, was it something else entirely? An observation mechanism, a surveillance probe drifting through our system, recording, transmitting, learning? Every explanation sounded like science fiction, but every alternative violated physics even more. And the strangest part? The beam didn't flicker. It held steady, consistent, unwavering, like a perfect optical alignment under intelligent control. When asked about it in an interview, Loeb's response was chillingly simple. No known natural process in the universe can produce a coherent, forward-directed beam of light from an icy comet nucleus, no known process. Think about that. Every law of thermodynamics, every rule of radiation physics says this should not exist. And yet there it is, right now, streaming silently through the void, its headlight cutting through cosmic night, aimed exactly along its path of travel, as if it knows where it's going. The more astronomers looked, the less sense it made. If this were a random fragment from another system, the odds of even detecting it would already be astronomical, on the order of finding a single marked grain of sand across every beach on Earth. But in less than 10 years, humanity has detected 3 such visitors, Oumuamua, Borisov, and now Atlas. Statistically, that's nearly impossible, unless something wants to be found. It's not just the frequency, it's the pattern. Each object more anomalous than the last, each arriving on increasingly precise hyperbolic trajectories, each raising more questions about whether these are natural wanderers or messengers. And then, as 3 I/ATLAS approached the orbit of Mars, something else began to unfold, something even the most optimistic scientists hadn't prepared for. The object's behavior changed again. Its velocity, once precisely modeled, began showing minute deviations, shifts too small for casual observers to notice but undeniable in the data. It wasn't drifting randomly, it was adjusting course. Even a fraction of a degree matters when traveling at over 100,000 miles per hour. Those small deviations, precise, consistent, were exactly the kind of movements you'd expect from something executing controlled navigation. NASA's Jet Propulsion Laboratory reviewed the data, then ESA cross-checked it. Both reached the same conclusion. There were unexplained perturbations in the object's trajectory. Publicly, the term perturbation sounds benign. Technically, it means something's pushing it, but we can't explain what. Internally, the conversation was far less calm. Something was steering 3 I/ATLAS. By late September, 1 month before its predicted perihelion, the closest approach to the Sun, the tension among researchers was palpable. Every telescope on Earth was watching, waiting, calculating. But then, a twist no one saw coming. The exact moment of perihelion, the climax, the point of maximum solar interaction, would occur not in plain sight, but behind the Sun. The object's path was perfectly timed so that as it whipped around our star, it would be hidden from Earth's view, lost within the solar glare for weeks. Astronomers call this phase the superior conjunction. For conspiracy theorists, it's something else entirely, the perfect cover. Think about it, an interstellar object with a forward-projecting beam approaching the Sun at impossible speed, entering a total observation blackout, right at moment it could perform a gravity-assisted slingshot maneuver. Coincidence? Maybe. Or maybe design. For now we can only watch and wait, because by the time 3 I/ATLAS reemerges from behind the Sun, our instruments will have missed everything, every transformation, every potential maneuver, every secret act it may have performed while hidden in that blinding glare. We won't see it again until December, and by then, it might not be the same object anymore. The universe has a sense of timing that borders on irony. We spend centuries building technology to see deeper into space, only to have the most extraordinary event unfold precisely where we cannot look. As one researcher said quietly during a late-night call with NASA's coordination team, if this thing wanted to perform a maneuver without anyone watching, this is exactly how it would do it. The silence that followed was heavier than words. For now, all we can do is measure, predict, and hope the data still makes sense when the Sun's glare fades. Because if it doesn't, if 3 I/ATLAS reappears with altered trajectory, composition, or luminosity, it will mean that something out there has just changed the rules of celestial mechanics. And we will have to face the possibility that, for the first time in human history, we have been observed in return. For several agonizing weeks, the skies fell silent. Every telescope that once captured 3I/ATLAS's violent brilliance now stared helplessly into a blinding sea of solar radiation. The object was gone, completely swallowed by the sun's glare. Humanity's instruments, our most powerful machines for observation, were rendered blind. And in that darkness, a question echoed louder than ever. What is happening right now on the far side of our star? Astronomers could only model, simulate, and guess. Would the object survive its fiery dive toward the sun? Would it disintegrate like so many fragile comets before it? Or, if the wildest theories were right, would it emerge changed, transformed, perhaps even reborn? Every scenario was on the table. Every possibility, no matter how absurd, seemed suddenly plausible, because this visitor had already broken every other rule. When 3I/ATLAS slipped behind the sun on October 29, 2025, we lost direct contact, but we didn't stop listening. NASA's Solar and Heliospheric Observatory, SOHO, began detecting strange rhythmic pulses in the surrounding plasma field. Normally, such fluctuations are attributed to solar activity, but these were different, periodic, ordered, almost artificial. For days, analysts pored over telemetry, filtering noise, comparing frequency patterns. What they found sent chills through the control rooms. A repeating modulation, cycles of electromagnetic intensity that seemed far too structured to be random. It was faint, almost buried under the solar storm, but its regularity was undeniable. 4 seconds on, 2 seconds off, 4 on, 2 off, endlessly repeating. No known solar process emits that rhythm. Something, somewhere, was pulsing deliberately. Of course, the official statements were cautious. Data anomaly, they called it. Instrumental interference. But off the record, among the scientists closest to the project, the tone shifted. One of them reportedly muttered during a debrief, "If that's a signal, it's not coming from the sun." When December finally came, humanity held its collective breath. The moment of truth. The moment the object would re-emerge from behind the sun, visible once again to Earth's telescopes. The first reacquisition came from the Very Large Telescope Array in Chile, and the signal they detected stunned everyone. 3I/ATLAS was not where it was supposed to be. Its predicted post-perihelion trajectory, calculated meticulously using gravitational models and solar radiation pressure, showed where it should have appeared, but the object wasn't there. It had shifted by nearly 0.05 astronomical units, over 7 million kilometers from its projected path. That deviation wasn't random, it was directional. NASA's Jet Propulsion Laboratory confirmed the finding within hours. The orbital adjustment, they said, could only be explained by an external energy source, a non-gravitational acceleration. In simple terms, it had performed a maneuver. The global astronomy community was thrown into chaos. Conference calls erupted across time zones. Private Slack channels for interstellar observation groups exploded with disbelief. Nobody could reconcile the math. The energy required to shift an object of that mass so precisely, so deliberately, was astronomical. No comet, no natural body could do that unless it had power. In the following days, as telescopes recalibrated and trained their optics toward the newly reappeared visitor, more details emerged, and each one was more confounding than the last. Its coma, once a chaotic sphere of violent outgassing, was now calm, almost unnaturally so. The turbulent plumes had vanished, replaced by a thin, symmetrical haze surrounding a nucleus that was suddenly far more visible. The brightness dropped dramatically, but the shape of the core had changed. It was no longer a rough, tumbling rock. It was geometrically smooth. Images from the Webb telescope revealed something that no one could easily describe without trembling. The nucleus appeared to possess flat planes, sharp edges, and uniform reflectivity. It looked engineered. Not a ball of ice, not a jagged rock, but a structure. Some compared it to a metallic shard, others to a fragment of machinery. It was as if the violent eruptions that once obscured it had been a deliberate release, a kind of self-shedding process, burning off an outer shell. Theories flooded in. Had 3I/ATLAS undergone some kind of transformation during its solar passage? Was the intense radiation an ignition event? Or was the coma explosion we saw before perihelion not a breakdown, but a launch sequence? As absurd as it sounds, the evidence pointed toward intentionality. The forward beam detected before conjunction, still there. But now it pulsed, measured intervals of luminosity at consistent frequencies. Scientists tracked those pulses for days, plotting intensity curves, comparing wavelengths. The beam emitted not random noise, but narrow band coherence around 532 nanometers, the exact green wavelength used in terrestrial laser communication experiments. Coincidence or design? Avi Loeb, never one to shy away from the controversial, took to a global press conference. "This is not a comet," he said calmly. "It behaves with the precision of a machine." He laid out the timeline, how each anomaly stacked upon the next, how every natural explanation failed, the structure's endurance, its perfect perihelion timing, the laser-like projection, and now the orbital deviation. Then he dropped the line that would ripple across the world. If 3I/ATLAS changed its trajectory intentionally, we are not observing an object. We are witnessing a decision. The world froze. From that moment, the narrative left the confines of science. It entered philosophy, theology, politics, and fear. If a decision had been made, who or what made it? Government agencies scrambled for data. Intelligence satellites retasked their optics toward the region of space where 3I/ATLAS now drifted. But to their frustration, the object was radiating almost nothing. Its thermal signature was minimal, far lower than it should have been. It was cold, silent, controlled. For weeks, it hovered at the inner edge of the asteroid belt, its trajectory nearly stable, like a probe entering a holding pattern. And then came the second anomaly. On December 17th, multiple observatories simultaneously recorded a brief but intense microwave burst emanating from its direction, lasting precisely 1.8 seconds. The frequency, 8.5 gigahertz, right within the range used for deep space communications. SETI's Allen Telescope Array caught it. So did the Square Kilometre Array in South Africa. Within hours, the data spread through encrypted academic channels, analyzed frame by frame, waveform by waveform. The pattern wasn't random noise, it was structured, prime numbers. The sequence was unmistakable: 2, 3, 5, 7, 11, 13, 17, 19. Repeated 3 times, then silence. The last time humanity detected a transmission even resembling that pattern was never, because it had never happened before. The media went wild. "Alien contact," the headline screamed. Governments tried to suppress it, labeling the recordings unverified, but the raw data was already mirrored across dozens of independent servers. Amateur astronomers confirmed it. The signal was real. Within 48 hours, the United Nations called an emergency closed-door session. The term interstellar probe appeared in official documents for the first time. And yet, 3I/ATLAS made no further moves. No more signals, no deviations. It simply drifted, silent and watching, as if observing our reaction. Behind the scenes, physicists began constructing models to estimate its energy output. Based on the beam intensity, trajectory change, and radiation readings, they concluded that the internal power source, whatever it was, exceeded that of any known natural process. Some speculated a fusion core, others something far stranger, an artificial nuclear decay engine. The term nuclear-powered interstellar technology, once a fringe notion, was now being spoken in the halls of NASA and ESA. But there was something else, a pattern that made the entire situation even more chilling. When the object first appeared in July, its trajectory was traced backward using high-precision stellar mapping. Astronomers discovered that if you rewound its motion through space, it intersected precisely with the region near Proxima Centauri, the closest star to our solar system. That might sound trivial, but the timing wasn't. traveling at its current velocity, 3I/ATLAS would have left that region 42 years ago, the same year that NASA launched Pioneer 11, one of humanity's first probes to carry a message meant for extraterrestrial intelligence. A golden plaque showing our species, our location, our sun, a cosmic postcard saying, "We are here." Was that coincidence, or had someone answered? It's easy to dismiss speculation as fantasy, but the parallels are haunting. A technologically active object arriving from our nearest stellar neighbor decades after we broadcast our own coordinates. And now it sits silently between Mars and Jupiter as if waiting. NASA's latest radar echoes, captured just before it moved beyond range, revealed something else, subtle but staggering. The object emitted brief radar reflections with microsecond precision, as though bouncing signals back intentionally. Like sonar, it was scanning. If 3I/ATLAS truly is an engineered probe, its current position makes strategic sense. From the asteroid belt, it has an unobstructed view of Earth's night side. It can observe us continuously, shielded from the sun's interference. But observation for what purpose? Data collection, communication, preparation. Every possibility leads to more questions. Some researchers have proposed a more optimistic view, that it's simply curious, a long-range explorer cataloging biospheres. Others fear a darker explanation, a reconnaissance drone mapping habitable systems. Avi Loeb, ever the voice of bold speculation, summarized it best. If we built a probe and sent it to another star, this is exactly what it would look like to them. That's the paradox. Maybe we're just seeing ourselves reflected back across the cosmic ocean. Weeks passed. By early January 2026, the object's forward beam dimmed further, then flickered out entirely. The signal ended. Its luminosity stabilized, and radar contact faded. It became once again a faint dot against the black, but the silence is louder now than ever, because what it left behind, data, patterns, impossible physics, refuses to fade. We now live in a universe where alien spacecraft is not science fiction, but a legitimate entry in peer-reviewed journals, where the brightest minds of our planet debate not whether life exists elsewhere, but whether it's already here, and the questions multiply. If this was a probe, where is it sending its data? If it's powered, what sustains it? If it was built, who built it and why now? Some theories point toward an autonomous seeding mission, artificial probes distributed by civilizations millions of years older than ours, designed to awaken upon detecting technological radio output from young planets. If that's true, 3I/ATLAS didn't come here by chance. It responded. Others see it as a warning, a message encoded not in language but in demonstration, a display of control over energy, matter, and gravity itself. And then there's the most haunting thought of all. What if it is an alien but ours? A remnant of some forgotten era, an echo of human technology lost to time or covered by history's fog. That notion has found unlikely traction among fringe physicists who study temporal cosmology. Theories suggesting information or matter could loop through space-time. Perhaps, they whisper, 3I/ATLAS isn't from another star, but from another time. But that for now remains speculation. The data doesn't lie though. Every observation, every signal, every deviation is real, measured, recorded, verified. And as Earth continues to rotate beneath a dark and indifferent sky, somewhere beyond Mars, an object the size of a mountain drifts silently, perfectly stable, perfectly still. Its forward beam now extinguished, its mysteries intact. Maybe it sleeps, maybe it waits, maybe it listens. When it first appeared, we thought we were the observers. Now we're not so sure. What happens next will define our century, because when 3I/ATLAS finally moves again, and it will, we will have to decide what it means to be seen by something older, smarter, and infinitely more patient than us. Until then, the question lingers, whispered in observatories, in labs, and in the quiet fear of those who understand the sky best. Did we just witness the universe noticing us back? If you believe this story is over, think again, because somewhere beyond the sun's light, 3I/ATLAS drifts in silence. And when it stirs again, the world will never be the same. Stay tuned, watch the skies, because this is only the beginning.